One of the first things we're going to do is learn to name the carboxylic acid derivatives. What we're going to find is that the carboxylic acid derivatives are all named off of the carboxylic acid base names. So just for example, I have this chart here that has carboxylic acids with 1 through 6 carbons. We have the IUPAC name, like methanoic acid, ethanoic acid, and so forth. And then we also learned the common names for the carboxylic acids, formic acid all the way to caproic acid. And as we talk about the different carboxylic acid derivatives, what we're going to find is that we can name them using the IUPAC system, where we'll base the name off of the IUPAC name, or we can name those derivatives off of the common system, where we name them based off of the common name. In order to name acid chlorides, the basic rules are as follows. The carbonyl carbon is carbon 1, just like in the carboxylic acids. And then for the ending, if it was a carboxylic acid, you would have the ic acid ending. What we're going to do is change that to YL chloride to specify that it's the acid chloride. Or if it were an acid bromide, you would change it to YL bromide, and so forth. So let's work on this first one. We're going to name it using both the IUPAC and common names. So for IUPAC, we're going to start at the carbonyl carbon, make that carbon 1, number the longest carbon chain. So this has 4 carbons. 4 carbons is butanoic acid. But we want to change the ending. So what we're going to do is drop the ic acid and change that to YL chloride. So the parent is butanoyl chloride. So then, as far as the substituents go, we have just the 2-methyl group. So the IUPAC name for this would be 2-methyl butanoyl chloride. Now let's do the common name. For the common name, remember you don't give the carbonyl carbon a letter. We start with the next carbon, that's alpha, then beta, gamma, and so forth. Again, 4 carbons, the common name for a 4-carbon carboxylic acid is butyric acid. We use the same rules to change the ending. Drop the ic acid, change it to YL chloride, so this would be butyryl chloride. Now to put this name together, we have the methyl group, but for the common name, it's at the alpha carbon. So we would say alpha methyl butyryl chloride. For rings now, this is going to be a little different because the carbonyl carbon isn't part of the parent. We're going to say it's the parent functional group, but it's attached. And what we do is we name the ring and then follow that by the term carbonyl chloride. To specify that that group is what is attached to the ring. So if we look at the rules here, the ring carbon with the carbonyl chloride attached is carbon number 1. And then we would continue to number around the ring to give the lowest substituent numbering. So in this case, our parent is a 6-membered ring with the amino group. So the way we would name this, do your substituent first. In this case, we just have the one substituent. We have 2 amino, and without considering the carbonyl chloride, you would just name this ring as cyclohexane. So we write cyclohexane, and then to say that the carbonyl chloride is attached, you add that to the end of the name. It is acceptable to put a 1 in front of the carbonyl chloride to specify that that group is a carbon 1, but it's not necessary since, based on the naming rules, it's going to already be at carbon 1. If we're naming esters, just like carboxylic acids, the carbonyl carbon is carbon number 1. But what we see with esters is that you have some R group attached to the oxygen. So you have to tell the reader what that group is. So the first step is we name the R group attached to the oxygen. Then we name the portion derived from the carboxylic acid, and to specify that it is an ester, the way we modify the ending is we change the ic acid to ATE. So in this first example, our substituent on the oxygen is just a methyl group. Then we can highlight our longest carbon chain if we want, starting with the carbonyl carbon. And if you number out that chain, we have 5 carbons. So for 5 carbons, the IUPAC name is pentanoic acid. The common name for 5 carbons is valeric acid. So following the rules, what we want to do is drop the ic acid from either name and add ATE. So this would be pentanoate or valerate. So in this case, there's no substituents on the chain to deal with. All we have to deal with is the group on the oxygen. So for the IUPAC name, we would just start with the methyl and add pentanoate. And we do leave a space. If we want to do the common name, same way, start with the methyl, and it's valerate. Again, there's a space here. Let's do this slightly more complex example. In this case, our group attached to the ester oxygen is 4 carbons, so that's a butyl group. Then we have our parent chain. And if we number that, we have 7 carbons. 7 carbons comes from heptanoic acid, but instead of ic acid, I'm going to add ate as the ending. So that's heptanoate. So to put the name together, we start with the group on the ester oxygen, which is the butyl. Leave a space, then we add any substituents, which is 3,3-dibromo. And then finally the parent, heptanoate. Now, if you have an ester on a ring, you're going to name it like you would a carboxylic acid on the ring, and again, change the ic acid ending to ate. So for example, if we just had this, we would just name this 2-methyl cyclopentane carboxylic acid. Where we essentially name the ring as it would be without the carboxylic acid, and then add the carboxylic acid ending to say that it's attached. Well, when we change this to an ester, what we're going to do is drop that ending and change it to ate. The other thing we have to deal with, though, is the group on the oxygen. So just like we learned before, let's start our name with that. So in this case, it's an ethyl group. Then we'll name the ring. Again, that carbon of the ring is 1, that carbon is 2, so this is 2-methyl cyclopentane. And then it's not a carboxylic acid on the ring, it's an ester. So we call that carboxylate. Another variation where you can use this nomenclature is if you have a metal cation on the carboxylate anion. So you might remember on several occasions we've called this anion a carboxylate, and that's where this ester nomenclature is derived from. So you're just naming the R group that would be attached to this carboxylate to generate the ester name. So we can do this the same way if you have a metal attached. So this isn't a methyl or an ethyl, but it's a sodium. And then your chain here is 4 carbons, which comes from butanoic acid. So we drop that ending and change it to ate. So in this case, our R group, if you will, on the oxygen is sodium. And you would call it butanoate. If you wanted to do the common name, sodium, 4 carbons, comes from butyric acid. Sodium butyrate. Next, we're going to learn how to name amides. So the basic rules are listed as follows. As always, the carbonyl carbon is carbon 1, so we can go ahead and make that carbon 1. We have to name any alkyl groups on the nitrogen as N-alkyl substituents. And what that means is we actually put an N in front of their names to specify that they're on the nitrogen. Now in this first example, there are no R groups on the nitrogen. There's just hydrogens, so we're not going to use this step. But when we do, it's a little different than esters. So you don't start the name with those substituents. What you do is you just alphabetize them with any other substituents in the molecule. Then for your ending, it's again based off of carboxylic acid. So we change the ending of the name to amide, but it's a little different than some of the other cases where before we've always just dropped the ic acid. In this case, depending on what the actual name of the parent carboxylic acid is, you could drop the ic acid or the ilic acid or oic acid. And the reason that different things are dropped, it just has to do with making the name sound a little bit better. So what we're going to do as we go through some examples is look, if you have an oic acid, that's what we'll drop. If you have the ilic acid, that's what we'll drop. If you don't have either of those, then you just drop the IC. So in this case, let's go ahead and find our longest carbon chain. It's 5 carbons. So 5 carbons, again, we'll do both the IUPAC and common names. So here, there's no substituents or anything to deal with, so this is going to be fairly easy. 5 carbons for a carboxylic acid is pentanoic acid. So in this case, we drop not just the ic acid, but there's an O, so you drop the oic acid and change that to amide. So we have pentanamide. That's the name, IUPAC name of this molecule. Be careful, a lot of times people will mistakenly call this pentamide. And they drop too much, so this is pentanamide, not pentamide. For the common name, 5 carbons, comes from valeric acid. In this case, you don't have an oic or an YLIC acid to drop, so we just drop the ic acid, and this becomes valeramide. Let's do a couple of examples that are a little more complex now. So in this first one, what we see is that it's not just an NH2 on the amide, we have methyl groups. And the way that we name these, because they're on the nitrogen, we add an N with a methyl. We have a second one, so that's also an N-methyl. Here in the carboxylic acid derivative, there's just 1 carbon. So the IUPAC name for this parent comes from methanoic acid. In this case, we drop the whole ending, oic acid, and this becomes methanamide. For the common name, this comes from formic acid, and we would just drop the ic acid and the parent is formamide. So for this, we can generate either name by just writing the substituents followed by the parent. Now let's just do this for the common name because this molecule here is almost always referred to by its common name. The substituents, we have the two N-methyl groups. Just like if you had a 1-bromo and a 1-bromo, you would combine it to 1,1-dibromo. You're going to do the same thing here. So combine these into N,N-dimethyl, and then the parent, if we're doing the common name, formamide. This is a common solvent used in organic chemistry, often referred to as DMF. Now, if we do the second example, we only have one R group on the nitrogen. It's a propyl group. So that's N-propyl. Then our parent chain, we start at the carbonyl carbon, go out our longest carbon chain, out 5 carbons. If we do the IUPAC name for this, that comes from pentanoic acid. We're going to drop the oic acid. That becomes pentanamide. The other substituent that we have here is a 4-methyl. So now to generate this name, treat these two substituents as just any substituents that you would alphabetize. And we're going to alphabetize these based on the P in propyl, the M in methyl. So to put this name together, the M comes first, 4-methyl. Then you have the N-propyl. And then the parent is pentanamide. Again, remember you're alphabetizing these substituents by the M, not the N in N-propyl. Let's do one last example with amides, and that's when you have it on a ring. And basically, you're going to name the ring followed by carboxamide. And this is based off of how you would name a carboxylic acid on the ring. So this would be cyclobutane, carboxylic acid. And here's a case where we're dropping the YLIC acid. And to make that the amide, we have cyclobutane, carboxamide. So that's where we get to add the carboxamide to the ring. If you had any substituents, like say if you had an ethyl group, then you would number this so that that's carbon 1. The ethyl would be carbon 2, and you would just add that to the beginning of the name, 2-ethyl. If you had other substituents, you would just alphabetize them as always. The final carboxylic acid derivative we're going to learn to name are the anhydrides. And what we're going to find is that these are based off of the carboxylic acids that they're derived from. Just to show you what I mean, let's take acetic acid. If you take 2 molecules of this and you put those together in a reaction that loses water and then joins the oxygen of one carboxylic acid with the carbonyl of the other, we end up getting an anhydride. For reference, a way you can do this is add a dehydrating agent like phosphorus pentaoxide. But the way we're going to name the anhydride is based off of the carboxylic acids that would come together to make it. So for example, in this case, we've started with acetic acid, which is a common name, or you could call it ethanoic acid, is the IUPAC name. And when you join those together, you get the anhydride. So what we do is we just replace the ending acid with anhydride. So that means this molecule here, you can call that either acetic anhydride which is what almost everybody calls this, but you could also call it by the IUPAC name ethanoic anhydride. Now, if you have an unsymmetrical anhydride, meaning 2 different carboxylic acids would come together to make it, what you do is you alphabetize the names of those 2 things. So for the second example, what we would have, if we do this based off of the IUPAC name, we would have propanoic acid, because there's 3 carbons, and you would have 4 carbons butanoic acid. So to generate the anhydride name, just alphabetize those. So you have butanoic, propanoic, anhydride.